this video I'm going to look at how we differentiate trig functions such as y equals sine x and y equals cos x. Now what you can actually do is you can study the gradient graphs of these functions and spot that where the maximum and the minimum points are where we've got the turning point, so where our gradient is actually 0. So on a gradient graph, that's the places where it would cut the x-axis. What that shows is the derivative of sine x actually becomes cos x. Likewise, you can look at the graph of y equals cos x and study the gradient graph of y equals cos x and look at where is the maximum and minimum points where the gradient is 0 and look at where on a gradient graph that would intersect the x-axis. And what you find is the derivative of cos x becomes minus sine x. And in actual fact, this pattern continues and we can actually say that the derivative of minus sine x becomes minus cos x. So if y is minus sine x, dy dx becomes minus cos x. And then if we study the gradient graph of minus cos x, what we find is it follows the pattern of y equals sine x. In fact, I like to use this diagram here and say that how we differentiate these functions goes round and round in a circle. And, oh, that's supposed to be a cos. There we go. Sine x differentiates to cos x differentiates to minus sine x differentiates to minus cos x differentiates to sine x, and so on. So let's have a go at using the chain rule to differentiate some other functions involving sine or cos. Let's try differentiating y equals sine 2x. Using the chain rule to break this into two simpler functions and do a substitution, we can say, well, if we let y equal sine u and u equals 2x, the chain rule says if we differentiate each of those two simpler functions, well, sine u goes to cos u. And we differentiate it, and the derivative of 2x becomes 2. So du dx is 2. Chain rule says we multiply the result together to give us the derivative dy dx. Actually, that should be dy du. Sorry, that's my poor communication there. Multiplying the result together gives us 2 multiplied by cos u, which is cos 2x. Let's have a look at our knowledge of using the chain rule in the past. When we break it into two simpler functions, what that says is if we treat this as our variable, we differentiate sine in the variable, which we know goes to cos of the variable, so cos 2x, and then we must remember to multiply by the derivative of this here, which is our 2. So it becomes 2 cos 2x. Let's apply that to some other things. What about if we let y equal negative cos of x squared plus 1. Well, applying that, what I've just said is we treat this as our variable here. Negative cos, when differentiated, goes to sine x. So I'm going to have a positive sine of this, because this, remember, is our pretend variable. And then we need to multiply the whole thing by the derivative of this bracket. And the derivative of this is 2x. So we have 2x sine x squared plus 1. There are times where we do need to use the chain rule and we can't predict what the outcome is going to be. For example, if we want to differentiate something that looks like this, cos cubed, of say 4x plus 1 all cubed. Remember, when we cube or square a trig function, we write that in between these two parts. So this is actually cos 4x plus 1 all cubed. Well, we need to apply the chain rule to this because it's not as easy to predict its outcome. So let's have a look. We're cubing something, so therefore our u is going to be this, and we're going to say u cubed is what we want to differentiate, where u is cos 4x plus 1. Differentiating each of those two simpler functions, this one becomes 3u squared, and this one becomes, well, cos goes to negative sine, and don't forget we need to multiply by the derivative of this. So I'm actually applying the chain rule here as well, but this one's easier, becomes sine 4x plus 1. That's just gone off the end of the screen. Apologies for that. All right, so let me just write that underneath so you can really see that. Minus 4 sine 4x plus 1. There we go. Now what I need to now do is multiply the result of these two things together. 3u squared, well, u is this. So I'll tell you what, underneath I'll write 3u squared multiplied by minus 4 sine 4x plus 1, and we can tidy it up. All right, let's put u back in. Well, I want to square this whole function, and remember we put the squared in between, so it becomes 3 cos squared of 4x plus 1 multiplied by this, and then I can still tidy this up. All right, well, we can multiply the negative 4 by the 3 to give us negative 12 cos squared of 4x plus 1 sine of 4x plus 1. And that is the derivative of that.